All right, get ready, because today we're taking a deep dive into something seriously mind-blowing. Fermi bubbles.
Yeah, these things are huge GE, totally invisible, and they're like right in our cosmic backyard. What's wild is we had absolutely no clue they even existed until around 2010.
It's kind of crazy, right? Like, how could something that massive go unnoticed for so long? Makes you wonder what else is hiding out there in the universe.
Totally.
So for anyone who's just joining us, let's start with the basics. What exactly are Fermi bubbles?
Okay, so picture this. Two gigantic bubbles, each one of them a mind-boggling 25,000 light years tall.
Oh, hold on. 25,000 light years. To
Yeah.
put that into perspective for our listeners, how many Milky Ways is that?
Think about stacking 25 Milky Way galaxies, one on top of the other. That's the sheer scale we're talking about. And these bubbles are just erupting out from the center of our galaxy. It's like our galaxy decided to burp on a cosmic scale.
Okay, wow. I'm already having trouble wrapping my head around the size of this.
Yeah.
And to think, these are invisible to the naked eye. How did we even find these things?
We can thank gamma rays for that discovery. These bubbles were found using gamma ray telescopes, which are designed to detect a type of light that's far more energetic than anything our eyes can see.
So gamma rays, they're what, like a super high energy form of light?
Exactly. They're a type of electromagnetic radiation, just like the light we see, but way more intense, and they come from incredibly powerful events in space. Back in 2010, astronomers were analyzing data from the Fermi Gamma Ray Space Telescope. That's actually where the name Fermi bubbles comes from. And they noticed this strange excess of gamma rays.
An excess. Coming from where?
Right from the center of our galaxy. And when they looked closer, these gamma rays, they weren't just randomly scattered. They were formed into two distinct lobes, extending above and below the plane of our galaxy, the Fermi bubbles.
So it's like our galaxy has these two giant energy signatures blasting out of it. That's crazy. But what could possibly cause something that powerful, that big?
Well, astronomers have a pretty good suspect, and it's a familiar one for this show. The supermassive black hole at the heart of our galaxy, Sagittarius A.
Ugh. Sagittarius A, our old friend, of course. But I thought black holes were all about sucking things in, not blasting them out.
They do have a reputation for pulling things in, which is true. But here's the thing. When a black hole as massive as Sagittarius A, we're talking millions of times the mass of our sun, is active, it doesn't just gobble up matter, it can also shoot out these incredible jets of energy.
And these jets, they're what's creating these massive Fermi bubbles.
That's the leading theory. Imagine these jets, powerful enough to inflate bubbles 25,000 light years tall. The sheer energy involved is mind-boggling. And inside those bubbles, not empty space. They're filled with hot gas and supercharged particles, some moving at close to the speed of light, called cosmic rays.
So we're talking about like a cosmic particle accelerator.
Exactly. And those cosmic rays, they hold clues about the activity of Sagittarius A millions of years ago. By studying them, we're not just looking at these bubbles, we're looking back in time.
Whoa, hold up. Time travel via giant space bubbles. Okay, now you're just messing with me.
Not quite time travel, but as close as we can get in astronomy. Light travels at a finite speed, so when we observe something that's thousands of light years away, we're seeing it as it was thousands of years in the past.
Okay. I think I'm starting to grasp the concept, but I gotta ask, why should we down here on Earth really care about these Fermi bubbles?
Well, aside from the wow factor, they give us this amazing opportunity to study some really fundamental things about the universe. I mean, this is a giant natural laboratory right in our cosmic backyard.
What kind of stuff can we learn from a giant space bubble laboratory?
Think about it. Galactic evolution. These bubbles are evidence of our galaxy's wild past, with Sagittarius blasting out energy and shaping the galaxy as we know it. Black hole behavior. We're getting a glimpse into how these supermassive black holes work, how they interact with their surroundings. And on a broader scale, it gives us insights into the very fabric of the universe. The cosmic rays, the magnetic field, all this stuff is interconnected.
So it's not just about what we're seeing now, it's about piecing together the history of our galaxy and the incredible forces that shaped it.
Absolutely. And perhaps the most exciting part is that the Fermi bubbles have raised even more questions than answers. Are these bubbles unique to the Milky Way? Do they influence star formation in the galaxy? There's so much more to explore.
It's kind of humbling, really. This discovery reminds us that even in our own galactic backyard, there are still vast mysteries waiting to be uncovered.
And who knows what we'll find next? What other secrets the universe is hiding?
Well, on that note, we'll leave you to ponder those cosmic mysteries. Thanks for diving deep with us today, and until next time, keep looking up.